Hello. In this video, we are going to take a look at another example of taking parametric equations to find what is this curve describing. So first, we're going to make a brief table of values using theta. These t's should be thetas. Theta, x, and y. And we are going between 0 and 3 pi. So I'm going to pick some values between 0 and 3 pi, pretty evenly spaced. You can do 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, and 3 pi. And now getting x and y is just taking these thetas and plugging them in. So plugging 0 in to 2 sine of 0 is 0. And plugging 0 in, we'd have 2 cosine of 0, which is 1. When we plug in pi over 2, we have 2 sine of pi over 6, which comes out to be 1. And 2 cosine of pi over 6 will come out to be root 3. Plugging in pi, we have 2 sine of pi over 3, which is root 3. And 2 cosine of pi over 3 is 1. 3 pi over 2 will give us 2 sine of pi over 2, which is 2. And 2 cosine of pi over 2 is 0. And finishing this out, when we plug in 2 pi, we'll have 2 sine of 2 pi over 3, which is root 3. And the 2 cosine of 2 pi over 3 is negative 1. Plugging in 5 pi, we'll get 1 and negative root 3. And plugging in 3, we will get 0 and negative 2. This should have been 2. I think I said 2, wrote 1. Now, plotting those points. When we plot the xy, it is just looking at this part of our table. So plotting these 1, 2, 1, 2, 1, 2, 0, 2 is on the y-axis. 1 root 3. Root 3 is closer to 2 than it is to 1. And then root 3 comma 1 to 0. 1 comma root 3. Or that was root 3 comma negative 1. 1 comma negative root 3. And 0, negative 2. Kind of looks like a parabola again. However, that is more my drawing abilities than it actually being a parabola. Because one thing sine and cosine should make us think of is circles. So, is it possible to use sine and cosine to get something parabola-like? Yes. Is it more likely we have a circle here? Yes. So, this is more supposed to be a right half of a circle, and we are going to eliminate the parameter to see that. So in C, we want to get rid of theta. Now, solving these equations for theta could get complicated, but knowing that maybe a circle is what we want to go for, I'm going to use my generic equation of a circle, that x squared plus y squared equals r squared. and see if that can actually get us an equation without theta. Or in particular, can we find an r squared that would make this work? So plugging in our x and y, 2 sine 1/3 theta squared plus 2 cosine of 1/3 theta squared equals r squared. This gives us 4 sine squared 1/3 theta plus 4 cosine squared 1/3 theta equals r squared. Factoring that 4 out, sine squared 1/3 theta plus cosine squared 1/3 theta equals r squared. We know sine squared plus cosine squared equals 1. So that means this piece here is just 1, and 4 equals r squared. Meaning our equation in terms of x and y is going to be x squared plus y squared equals 4, where y, because we have the whole left half of the circle, we have y between 2 and -2, but we only have the right half of the circle, so x is between 0 and 2. So there is our equation of a circle. Out our parameter. And then the last thing describing this curve is exactly what has been said. It is the left half, the right half of a circle that is centered at the origin with a radius of 2. There is our parametric curve, and to know how theta is increasing, we sketched this going from the top to the bottom. So there is B fully answered. And as we describe this, we can describe that it is sketched in this is a clockwise direction. And there is another example of finding the XY equation from a parametric equation.